So in this chapter, we're going to be studying the real numbers and their properties. This is section 5.5 in your book. What you will learn in this chapter is the property of real numbers. We'll talk about the real number set. We'll talk about closure. And we'll talk about some basic algebraic principles like the commutative property, the associative property, and the distributive property. Real numbers is the set of real numbers is formed by the union of the rational and irrational numbers. The symbol for the set of real numbers is the set symbol, with the R in it, or it can be represented as a parentheses with the infinity, negative infinity, comma, infinity symbol. Sometimes you will see in books this shape of R for all real number sets. So going from left to right, or from right to left, we see that the integers are made up of the natural numbers, 0, and the negative integers. They all make up the integer set. Fractions, which is any number that is divided by another number, is called a fraction. And if we put them in decimal forms, we sometimes see them as terminating or repeating decimal numbers. All of these numbers are called rational numbers. So the rational numbers include integers and fractions. And finally, we have something called irrational numbers. Irrational numbers are those numbers that don't terminate or repeat in decimal numbers in decimal form. So the square root of 2, the square root of 3, pi is an irrational number, and the little number e is also an irrational number. And the rational numbers, along with the irrational numbers, make up the whole number set. So the whole number set, the real number set, is made up of all of these numbers. Sometimes we call pi and e transcendental numbers, and we will get into more of those numbers later on in our chapters. So one of the properties of the real number system is called closure. If an operation is performed on any two elements of a set and the result is an element of the set, we see that the set is closed under that given operation. Although we haven't talked about sets yet, we can see that if we add two real numbers, we're going to get a real number. That is the idea of closure. So now we're going to talk about some other properties that are algebraic in nature. The first one is called the commutative property. What I call it is the rearranging property. For addition, if I have a plus b on one side of the equation, I can rearrange that to be b plus a. The numbers on the left-hand side is going to be equal to the number on the right-hand side. The commutative property for multiplication is very similar, except we use the multiplication symbol. So in this particular case, we have a times b is equal to b times a. That makes sense since the number on the left-hand side is going to be equal to the number on the right-hand side. And this is for any real number. We also have the property called the associative property, which I call the regrouping property. So for addition, if I have, for example, parentheses a plus b, we would do that operation first, and then we would add c. We see that this is equal to a, plus the group B plus C. For multiplication, if we multiply A times B first in parentheses and then multiply it by C, it's the same number when we have A times the grouping of B times C. This is called the associative property, and this is true, there's closure, for any real number A, B, and C. And finally, we have something called the distributive property of multiplication over addition. Actually, I just call it the distributive property. And it works both ways. For example, if I multiply A times B plus C, I can multiply these through, A through, and we get A times B plus A times C. Likewise, I can go in reverse. I can take an A out of these two terms and get the result in this direction. So either way, the distributive property works either from left to right or from right to left. Now we're going to work a few problems. For part A, name the property illustrated. So here I have 2 plus 5 is equal to 5 plus 2. I'm just rearranging numbers in the addition, so it must be the commutative property of addition. B, parentheses, x plus 3 plus 5 is equal to x plus 3 plus 5. I've just regrouped. So under the regrouping principle, it must be associative property. Now, number C. 4 times parentheses 3 times y is equal to parentheses 4 times 3 times y. Well, I've just regrouped. It's the associative property, and since I'm using nothing but multiplication, it must be the associative property of multiplication. Some additional examples. We'll look at number D. 9 times parentheses w plus 3 is equal to 9w plus 9 times 3, which is 27. This is the distributive property. Part E, 5 plus parentheses z plus 3 is equal to 5 plus 3 plus z. It's the commutative property of addition. There was a trick. Notice that the only thing that I rearranged was inside the parentheses. So it is commutative. Again, we're going to identify the property that's illustrated. So we have parentheses 2p times 5, which equals 5 times 2p. This again is the commutative property of multiplication. In many cases, we will simplify our result. If we have 2p times 5, we will also end up just going 10p. That makes sense. So here we have a little bit more complicated problem, number A, where we have 5 times 2 plus the square root of 3. So now we multiply 5 times 2, and then we multiply 5 times the square root of 3, and we end up with 10 plus 5 times the square root of 3. We completed the operation. Part B, we're going to see the same thing. We have the square root of 7 times parentheses 4 plus the square root of 2. We multiply the 7 times the 4, we get 7 times the square root of 7 times 4, plus the square root of 7 times the square root of 2. And now we end up with the following: 4 times the square root of 7 plus the square root of 14. The radical symbol is just presented with the multiplication of the inside of the two numbers when we multiply. Again, we will use the distributive property to simplify our result. This should have been, this is not exactly correct here, so I need to get rid of that. What we had was 2 times x plus 5, and this was in parentheses, by the way. And now when we do the distributive property, we see it's 2x plus 2 times 5, and now we will do the operations on each of the terms, and we get 2x plus 10. Well, this concludes our examples and of the topics in Chapter 5.5 that are important to us. We will begin talking about